this gadget electrolyses salt water to produce a cleaning fluid, and it's blown up. Now the reason was that the lady got confused with which power unit to plug into the unit. Now this is the correct one. It's a 5-volt supply on this plug. However, she couldn't find it. Thought that this one was it, and plugged that in, and hey presto, blew it up. Now I have removed the circuit board. I've taken out the chip that has blown up. I've wired it up to test this part of the circuit because what's happening on pin 5 is quite different from everything else, and I'll try and explain what I think is happening. The cathode and anode are plates in the electrolysing unit, and the MOSFET switches on the 5 volts supply, and that goes down through these low ohmic value resistors to ground. The voltage developed across those is according to the current flowing, and I think pin 5 of this device is used to monitor the current flow. Now that means to say that this pin 5 is an analog input. I chose to put a PIC 12F683 microcontroller into the circuit here because I reckon that I can program all the pins as necessary to do the job that's required. And that is on pin 7 we've got a pull-up resistor to the 5 volts. The momentary on switch pulls it down to switch the unit on, and when it goes on, pin 2 goes low, and so it goes from 1 goes low, and switches the red LED on. Pin 6 goes high and switches the MOSFET on, which starts the process. Pin 5 is monitoring the current, and after 10 minutes, so we've got a timer function in here, after 10 minutes it all switches off and the green light comes on to say the process is complete. That's it. And the purpose of this circuit is to monitor the currents, and so that we can decide upon what current limit we need to set. Broadly speaking, we don't want it to exceed 1 amp, which this unit is rated at. Alright, I've got the right unit plugged in. I shall plug that in and put that down. In here is 450 millilitres of water and a quarter teaspoonful of salt, and we're getting a current round about 0.8 of an amp. Let me zoom in a little bit and show you that. The current fluctuates between 7 and 8 throughout the process. It really is a question of how many gas bubbles are clinging to the anode or cathode. As you see, we just had a bubble pop away from the thing. It's popped up to 0.9. Right. I'll switch the unit off and replace it with fresh fluid, but this time I'm going to add half a teaspoonful of salt, and we'll see what happens to the current. I've replaced the quarter teaspoonful salt solution with a half teaspoon salt solution, and now we'll plug in the device and see what the current leaps up to. And it's, as you see, if you notice, it's gone right off scale, and I'll have to go on to 10 amp range now. And if you can't see it, or you want to take my word for it, it's about 1.4 amps. Well, not that that's any better, but it's about 1.2 amps now. Let's give it a bounce. Let's see, yeah, 1.3. Whilst the power supply is able to take that, it is now outside of its design limitations, which is 5 volts 1 amp. It seems logical to me to limit the current to 1 amp. Perhaps it was a bit obvious in the first place. We don't want to go and blow up the power unit, and I'm sure there's some clever souls out there would think that by increasing the amount of salt in the solution that you would strengthen the liquid, which is probably not so, or would it? Who knows? But as we want this device to continue forever and a day without causing us any problems, 1 amp it's going to be. I want to come clean at this point and show you that this is the first microcontroller that I've ever programmed or written software for. I relied heavily upon tutorials here, there and everywhere on the internet, and the one I got most out of was from circuitbread.com, and they have 2 tutorials covering microcontroller units. To get me up and running, I thought I'd go through those tutorials, and I purchased the various bits and pieces I needed. And while I was waiting for them to come through, all of a sudden the penny dropped, and so I ended up skipping them and ploughed straight into getting on with getting the job done. I come at this from a repair point of view, not a sort of, oh, I want to learn about microcontrollers. I don't want to learn about microcontrollers. I just want to get the job done, and that's very much what I'm doing. Now, I tackle it a little bit differently from other people. Well, at least I think I tackle it a little bit differently. And it's about understanding the microcontrollers, and once you know how they work, and away you go. It really is quite a simple process at the end of the day. Now, I did all my work on a small development breadboard that I made up with all these plugs and bits and pieces and that. And I wish that I'd used a copper strip board and hardwired everything and made up a nice little model, because these things are so, well, they can cause you a lot of problems with, especially if you haven't got a good connection. And that happened to me a couple of times. There's a drawback to all of this, and it's this thing. This is a PICKIT 3. The job that this has to do is to get the information off of your computer and program your chip down there. Now, it does it very much in a similar way to the way we sort of program EEPROMs, and if you're familiar with programming EEPROMs, then you'll be familiar with these little devices, which is the CH341A. Now, you can buy these for about £5 or £6. This cost me £27. I think it was £27. It may have been a little bit more, it may have been a little bit less, but I think it was £27. And it may even be a clone. I'll go into that in a little bit detail now, because you need to be aware of this problem. But honestly, £27 to program a chip that's 80p as a one-off job is ridiculous. And there's got to be easier ways of doing it. And I've seen people mention using Arduinos to do this, but I've not followed it through or seen any of the details. But I'm now going to talk about this little PICKIT 3 for a couple of minutes. Now, what's the problem with these PICKIT 3s? Well, one, the latest PICKIT that's produced by Microchip is a PICKIT 5, and I think when I looked on their website a week ago that they are run at about £80 in the UK. This PICKIT 3 may be a clone, probably is a clone. However, you will notice other clones that have miss off the logo, so they won't have the logo on there, the Microchip logo, that'll be missing, and just have PICKIT 3. And there is a version out there called a PICKIT 3.5, and as far as I know, Microchip have never produced a PICKIT 3.5, so that's definitely a different beast. They went PICKIT 3, PICKIT 4, and then now it's PICKIT 5. If I haven't said it already, the PICKIT 3 is no longer supported by the latest software from Microchip, the development software. That's IDE. It's an integrated development environment, and their name for their one is MPLAB X, I think that's right. So you pays your money, you takes your chance, and it's a lot of money if you're only doing one of them. So if you know anybody who's got one, try and borrow it from them, and it would be nice to try one before you sort of bought one. And I can't recommend any of them to you. If I could, I would, but honestly, I don't know. I've seen the odd person saying that you can use an Arduino to do the job for you. I don't know how, so you'd have to search that out beforehand. But for a bit of fun, it might be a good idea to get yourself an Arduino if you've already got one. See if somebody on YouTube is showing you how to do it, and follow that through. It may be an alternative to using a PICKIT 3. I'm going to look into it at a later date in the future, but please don't hold your breath, because I've got so many other things to do. Now, I've waffled enough about them. What a shame though, I mean, honestly. You must think me a right idiot paying 27 quid to program an 80p chip. But it's something I wanted to do, and I do this for fun, nothing else, purely fun, and I enjoy it. It's a hobby. Now let's move on and get on to the software. Now we're going to download the software, which is the MPLAB X, which is the IDE, that is the Integrated Development Environment tool from Microchip, and I'm going to walk you through the process of installing and using that, and we're going to use, in conjunction with the specification sheet for the 12F 683 microcontroller, we're going to get the job done, which is to get this gadget up and running again. Although I'm calling this a one-off job, I suspect that as I go along and get things to repair from, to break around the house, there's more and more units have got these little microcontrollers in them. And it's the second time this year that I've come across a microcontroller and popping up in something. First time it was just a big no-no for trying to fix it, because I didn't want to do it. If you're okay about downloading and installing software, then the next 20 minutes will be fairly useless to you. And providing you're using a PICKIT 3, then this link is the one I recommend. And I'll leave it in the description. And scan down the page till you get to the MPLAB X IDE archives. And page 9. And this is the last version that supported the PICKIT 3, and that's the version 6.05. That's one you need. Right, now as regards installing, as you can see, it works on Windows, Mac and Linux. We'll jump to this next link, and here you've got all the walkthrough requirements for the operating system you require. Now I'm using Linux Mint, and it looks like if I'm installing it on a Linux system that I'm going to have to use terminal. Now I don't use terminal, and if you're interested you can watch the next 20 minutes. If not, just run through this. If you're quite okay using terminal, just run through this system and everything should be okay. I think that's about all I've got to say about that. Oh yes, well, links do change from time to time, and these are as of August 2023. I think that's it. Before I forget, you will also need another piece of software which is called the MPLAB X IDE compiler. Here's a link to it. I'll put that in the description, and if you're like me, are doing an 8-bit microcontroller, then this is the one you want. Here's one for the 16-bit, and here's one for the 32-bit. And if you're okay with all of that, you can skip the next 20 minutes. To download this software, we need to go to the microchip website. So we'll open our browser, type in MPLAB, and come down here until we find microchip MPLAB X IDE. Accept cookies, and we can download the MPLAB X IDE. As you can see, it's cross-platform, in that it will run on Windows, Linux and Mac operating systems. Now, the bad news is the current version doesn't support the PICKIT 3 that I've got. And if you've got a PICKIT 5, this is the only version that will support the PICKIT 5. PICKIT 4, you're okay. PICKIT 5, you're okay. If you've got a PICKIT 3, you have to go to the Downloads archive, and every version they've produced is here. Go to the page 9. This is the last version that supported the PICKIT 3, and as I've got a Linux machine and I'm running Linux Mint, this is one I've got to download. You will have to download the flavour that you need. Click on download. It's a fairly large file, almost a gigabyte. We've now downloaded it. Okay, close the browser. I'm going to my downloads folder. And here we have a compressed file. Right click on the mouse, extract here, and you will see we have this MPLAB Linux installer.sh. I wasn't really expecting that, and you will have to probably at this stage scream and think, oh, I've got to use the terminal. I don't want to use the terminal. But I do want to run this file. Right click again, you'll come down to properties and we'll look at permissions, and it says that we allow executing file as a program, which is exactly what I'm going to do. Go back, right click on your downloads folder, open as root, type in your password, and wait until you get the authorization. Now, anything we do in our downloads folder, we have root control over. Just left click, run in terminal, forward, I accept the agreement, forward. This is going to be our install directory. You might find this a bit funny when you come to look for it, but if you're not used to rummaging around your file system on your PC, but I'm leaving it there because it makes life easy. It says I consent to allow the collection of anonymous information. No, I don't. I would like to enable product changes notes. This will enable us to share data, product and tools I use. No, forget all that. Don't want to. Not interested. Use system proxy settings. No proxy. Okay. Choose which applications you want to install. Now, at this point, I'm dealing with an 8-bit microcontroller. There's a 16-bit versions, 32-bit, and other MCUs. Now, for the purposes of what I'm doing, as I said, I'm using an 8-bit controller, and I just want support for the 8-bit one. So let's deselect these. Okay. Forward again and wait for it to install. Interesting. Okay. Looks like we'll have to reboot. I don't want to launch it at this point. Finish. Have another go in a minute. X. Restart. Programming. MPLAB X IDE. Click on this to open it. And we'll have to wait a couple of seconds because it's checking to see if it's got the necessary requirements. This is telling us we do not have a compiler installed. Okay. Go to Learn and Discover and MPLAB XC compiler, and that is what we want. And a cup of tea has just arrived. Hooray! Click on that. That takes us over to the microchip website. Now 3 compilers available, one for 8-bit microcontrollers, the other 2 for 16 and 32-bit controllers. Let's accept all the cookies. I'm using an 8-bit and that's what I need, so download it 8-bit. Now, before I do that, I should say that we also have an archive where we can download an earlier versions of the MPLAB X IDE compiler, should we need to. So if we run into any problems, we might have to go back to this archive and find an earlier version of this, but I don't think we'll cross that bridge if we need to. Download the X IDE compiler. And again, we've got 3 options, one for Windows, one for Mac and another one for Linux. I'm running Linux Mint, we're going to download that. And if you're very observant, you'll notice this is the third time I've actually downloaded this program, as I'm having lots of trouble doing the recording today. We can close this window down, minimise the, no, in fact we'll close MPLAB down, exit, go to the home folder, go to downloads, and we'll now run the compiler. But first, right click, check the properties, check the permissions, and you'll see we are allowed to execute the file as a program. Now, before doing that, go back to the downloads folder, right click, open as root, otherwise the program will not run. Put in our password, left click on the program and the compiler will begin to install. Next, I accept the agreement. Next, we want the free version. Next, I'm leaving it in this directory. Apply settings to all users of this machine. Next. Well, we're now ready to start installing it. Next. Now here we're being asked to click for purchasing, click here to get the 60-day evaluation and click here to activate your license. Ignore all of that, as it says if you want to use the free MPLAB X C8C compiler, click next, and that's what we want to do. And next question is finish. Close that down, close that down. Let's open the MPLAB X IDE again by going to Program and clicking on the IDE. We're open. Now, one last job before we start in earnest is that we're going to need a data sheet for the chip that we're going to program. And back to the website again. I've previously downloaded it, of course, but we'll download it again. Data sheets, title. Right, well, there's thousands there. We can put in our search documents for a PIC 12 F683. Search. Right. Oh, accept cookies. Then we have the data sheet. Click on there, which opens the data sheet for us. Come up here, and we're going to save. Right, I think that's all we need to do for now. We'll come back after we've drunk our cup of tea and start work. Just for fun, I'm going to try installing the software via the terminal. I already have it downloaded and it's here in my downloads folder. I'm going to extract the information from the compressed file first by right clicking and selecting extract here. And there's the file. We're now going to go down this to properties, permissions, and check that we're allowed to execute file as a program. Close. Go back up to Roger. Right click on the downloads folder and select open in terminal. List the contents of the downloads folder. Highlight the file that we wish to install. Copy. In here we're going to type the command sudo / right click and paste the name of the file we want to install and press return. Password, and away we go. Now, if you've never done it before, these are the only two things you have to remember. Hang on, let's move that down. The only two commands that three commands that you need to know are ls to list what's in the folder. You need to be able to paste and copy the name of your file that you wish to start. And in this instance, because it's an sh file, you sudo / followed by the file name. Now, from here on, it's just a question of following the instructions we see in the setup procedure. Accept the license agreement. I don't want any proxies. I don't want any consent stuff. Get rid of all that. MPLAB X IDE. Yeah, I'll leave those two. Well, definitely got to have the first one. Optional if you want to choose that one, but I'm leaving it in. 8-bit processor I'm using, so let's get rid of these. And forward. All those other options can be added at a later date if needed. Forward again. And it says a reboot is advised. Well, we won't do that just for the moment. We could launch straight away, and down here it says XC compilers are not installed with the IDE. Go to microchip to download a compiler. Back in our downloads folder, we now want to install the compiler. We'll do much the same as we did for this one, which is to right click on it, come down to properties, check the permissions, and as you can see it's allowed executing files and program. Close, go back to our downloads folder, right click downloads folder, open in terminal, list the contents of the downloads folder. Highlight the compiler, right click, copy, come down to here to the downloads, type in sudo / right click our mouse and paste in the name of the file we wish to run. And job done. Type in our password, and away we go. Follow the instructions on screen from here on. Next. I accept the agreement. Next. I want the free version. Next. Install directory. Next. Leaving it where it was. Apply settings to all users of this machine. Yes. Next. And we're ready to go. Now you don't want the any of this. You don't want a pro license. You don't want a 60-day evaluation, and you certainly don't want to create an activate your license. It says if you want to use the free MPLAB X IDE C compiler, click next and finish. All that remains now is for us to close this down and reboot the computer, and our install will be complete. Now I personally think that this is easier than what I've just done without using the terminal, so give it a go. As I said before, the only thing you have to remember is the ls command, which lists what's in the directory, the sudo command, which gives you root control, and it's / before the file name you wish to install in this instance. And there's a nice easy way of getting the files you want just by highlighting the file, right clicking, copy, and then come back down here and you can paste it in by right clicking and paste, and that's how to save yourself a lot of typing. Right, now to close down and restart. We have the software open, and there's no point me telling you this is going to be easy, because it isn't, and it can be very dull trying to explain things. And if you've got to wind a video backwards and forwards, it's no fun. So I found circuitbread.com on their website have tutorials on embedded C programming for microcontroller units, and they have the instructions written down there. And I think you'd also probably find all the instructions for opening a project file and setting up files, etc. are probably all written down on the microchip website. And so I'm not really going to cover it in too much detail, and I'm going to probably fly through this bit if I can. New project, microchip, embedded standalone. Basically speaking, I just want to get the job done. That's what I used. Next. I'm not going to worry about anything here. It's a PIC 12. So PIC 12F683 that I'm using. I'm not bothering about the tool at present. There's a list of them, and as you can see, this version does support the PICKIT 3, which is the one that I've got. Next. I haven't got any other things. I haven't got this, so it's none. Next. I'm going to download that compiler. Or not download it, but that's the compiler that I'm going to use. Next. My project needs a name. We're going to call it Rogers. That'll do. Finish. Need a new file. Microchip embedded. Expand my options. We're using this compiler and it's a main C. Basically we're choosing main C because we're going to use the computer language C to do our programming when we need to. Right, we need to give the file a name, and I'm going to call it Rogers 001. I'm not putting the apostrophe in, guys, just take it as read, please. And yeah, that's all okay. Finish. There it is up there for all to read. These sort of not part of the programming, just sort of meta information that about what's going on. Right, we're almost there. We now need to set up the sort of configuration files for our little microcontroller. To do so, we go to a thing called production. Go to production, set configuration bits. And we've got this list of options here. Now, confusing? Yep, of course it is. And it's nothing to do with computer, well, perhaps it is to do with computer programming, but not what we are interested in. We've got to set these to configure our device to work how we want it to. Right. I'm not sure whether to choose that one or that one. Choose that one. That'll do. It says internal oscillator input output functions. Oh, yeah, okay. I'm not going to use them. WDTE on, watchdog timer enabled, don't want that. Power up timer enabled, don't want that. That's off, already off, so leave it as off. Master clear is on. Now, difficult one, this one. And I'm going to explain why it's a difficult one, but I'm going to switch it as off, and I'll explain a little later on what. No, perhaps I'll explain now. Let's see if I can find the. I did download the spec for this device, and in the specification sheet we can see that the master clear function goes to pin 4. The bar across the master clear function indicates that it is a not master clear, which means to say taking pin 4 low will initiate a master clear. Pin 4 is being held low by a pull down resistor, and therefore we are holding the microcontroller in a master clear condition all the time, and clearly it won't function properly. So therefore we need to switch it off. I hope that's not too confusing. Code protection bit, well, who's bothered? Off. Data code protection bit, off. Brownout detector, well, there's no brownout problems with this program. And so that's going to be off. And internal external switch over bit, oh god, off. And failsafe clock monitor, no, kill that. This is a very complex chip that we're using. Although it's only got 8 pins, it's got multiple functions and possibilities that you can do with it, and hence we have a lot of different things to select. Well, fundamentally what we're doing is very, very simple, and that's why a lot of these options are switched off. Okay, now how do we get all this configuration file up into our program file? And we generate the source code down here. Click on Generate Source Code and come across here, and this is the source code that is generated. As you see, we've got this hash include xc.h, which is the compiler routines, and we'll highlight all of those. Copy, and this is hash include that we've got here. Just highlight that and replace it by pasting what we just copied. We've now got to the point whereby pull that down, we've got our program here. Have we done anything wrong? Easy way of finding out, go up to our little build main project, this little hammer up here, click on that, and we get some information down the bottom here. It says that our build successful, total time 2 seconds, etc. So far so good and no mistakes. Now from here on we actually get into the nitty-gritty about the processor itself, and we'll be looking at the spec sheet, and I'm going to cover some points in there at a pretty basic level, and so help us understand it. And it really was the turning point for me once I understood what was going on in that 12F683 that made programming this chip with very little knowledge of C programming language possible. This is where the fun begins, and I'm going to type in DRIIO. Well, straight away I can see we've got a problem because the word should have been recognised by the compiler, and it hasn't been. So what I'm doing now is a little bit sort of irrelevant, but we've got to fix this. As it's not been recognised, we're getting an error messages here, and let us, I think, holding the control down with the arrow over the one that's causing a signal, it says, I suspect that we're either missing a library package, or alternatively we've got we need an earlier compiler. The chip we're using has been around since late 2008, 2009, 2010, that sort of date. So it's been around for a long time, and it may have been sort of dropped from the latest compiler for some reason. Now, how do we get around that problem? Sometimes you just have to wait for things to come through, and this is not working for us. Come up here, and we'll go back to the MPLAB X store, and no, that is not what I wanted. Come back to the start page, open Learn and Discover, this one here. Let's pull that down so we can see what we're talking about. MPLAB XC compiler. Downloads archive. We don't want the IDE. This is the one we want, the compiler archives, and we want an 8-bit one for a Linux machine. let's go to 16. Ooh, 2.4 there. 15th of August. No, 15th of July rather. Let's go a page back further. Now let's try one of these on this one. Last year, say, let's go back 1 year. We'll try the 236. You can see it's downloading up here. That's completed. Close this window down. We'll go back to our downloads folder. And it's this one we want. The 64-bit one. Go to properties, permissions. Yeah, we're going to have to allow it to be executed as a program. Go up again. Open that downloads folder in terminal. Type ls sudo dot slash 236 full installer and run. Copy. Paste. Type in the password. Install the compiler. I accept agreement. Free. Next. Next. I don't really understand that. Next. Next. We're going to have to keep on doing this until we get a compiler that will work. And oh, is that it? Or have we done something wrong? Oh, this is tiresome. We're going to load it again. File, project properties, try that one, apply. Okay. Hooray! You should now see that the TRISIO, which stands for Tri-State Input Output, has now changed to a power blue colour and indicates that it's being recognised by the compiler, which is good news for us. If you continue to think of this as a binary number, then all is lost. And I shall now explain why. I'll open the specification again, and this is the TRISIO, tri-state register, and we commonly think of this as being expressed as the tri-state input-output. The GPIO stands for, I think, general port input-output. Well, it says it all. The tri-state register is 8 bits long. Bit 0 starts at that end, and bit 7 starts at that end. And that's why we tend to think of it as a binary number. Now, let me show you what it really is. These arrows indicate that we can have processes going on in both directions. Up here it's obvious that the arrow is only going in one direction, and here it's only going in one direction. That's the, in this case, 5-volt supply, and that's 0 volts. And they're not part of the programming, but they are needed for the power, obviously. So our first port is GPO, and this port here is bidirectional, 2 directions, and we want to set that to go in one direction, and our on switch is connected to this one, so we want it to be an input. So we want this one to be an input. Pin 6 switches are on a MOSFET in our circuit, and therefore we want this to be an output. So it's input, output. This one's going to monitor the current being drawn. So it's an input. So input, output, input. This one can only ever be an input. It's got a direction, so that's an input. Let me repeat. Input, output, input, input. This one, pin 3, drives an LED. Pin 2 drives an LED, so these are both outputs. I'll repeat from the beginning again. Input, output, input, input, output, output. Now, we're going to go back and look at our tri-state register. Input, output, input, input, output, output. And we've still got 2 other bits here that are not actually used, and that is because we've got an 8-bit processor. And these are the 8 bits for each sort of register. And down here it tells us exactly what's going on. Bit 7 to 6 unimplemented, read as 0. Bits 5 to 4, there's 5 to 4, these 2. We can read these as a 1. It'll be configured as the input. So if that's a 1 and that's a 1, they'll both be inputs. And if they're 0, they'll both be outputs. So 1 for an input, 0 for an output. 1 for an input, 0 for an output. Bit 3, this one here, is it says here control bit, input only. So that's going to be a 1. And bits 2 to 0, that's 2, 1 and 0. Again, it's 1 for an input and 0 for an output. So let's recap. This is an input, so it's a 1. This is an output, so it's a 0. This is an input, so it's a 1. This is an input, so it's a 1. This is an output, 0, 0. Or, if you like, our on switch. This one switches on the MOSFET. This one monitors the current. This one is always an input. This one drives the lead on. This one drives the lead on. So 1 for an input, 0 for an output, 1 for an input, 1 for an input, 0 for an output, 0 for an output, and these two we're leaving at 0, 0. They're just switches, and they just set the device to have whether it's an input or an output on that particular pin. The 0B indicates that this is a binary number, although I look at it as just a row of 8 switches. This number could equally well be expressed as a hexadecimal number, which we've all just seen, by changing that to an X and that to a D and just deleting the rest of the row. Or we could express it as decimal 13. And equally, they're all valid, but I think, well, I certainly think that 0B 0001101 says an awful lot more about what's going on than either 13 or D, which you go, and I understand it that way. It's helped me get through the rest of my programming. Now, before we go any further, there's a lot more here in that statement than you might imagine, and it's all part of C programming. The equivalent sign here actually means that we're setting this output, and we could equally well have a different symbol there. We need this end of line statement here. They're all part and parcel of programming language, and if you really want to know anything about that, the best place to go is to open your browser, go up here and type W3 schools, and look up here. You'll see that they've got C. Click on that, and they've got loads of short tutorials on programming, and you can do little exercises on each page as you go along. It's a very excellent way of getting to grips with a few of the commands you might not understand. We'll be using the while loop. I don't know if I used the for loop, and I'll certainly use the if statement, and trying to think of what else I might be using. Well, if you need to, there's all this help here for you, and I found this website very useful, especially on some of the other programming languages. Now, you don't really want to spend your life being an expert in one, because there's so many to choose from, and even then there's sort of subsets within those. This is a wonderful website for either refreshing or finding out a little bit about other computer programming languages, and I've found it very helpful in the past, and I've found it helpful doing my little project here. So I hope that tip helps. Let's close that down for a moment, and I'm going to add the rest of the code and walk you through what I came up with to do the job. Well, here it is in all its glory. It's mostly about setting up the registers, and this one is to set the inputs, outputs, as I've discussed in detail. This one sets the analog input. This switches off the comparator, which gets in the way of some of the other functions. And down here, these are all part of the analog to digital control register, and could be expressed in one line, but I chose to do them individually, which you can do, but you'd have to refer to the register in the specification to know what's what. I make a lot of references as I go along so that I can remember what I did and why I did it. These come from the GPIO register, and I choose to set these individually as and when needed, rather than keep on sort of having this one-line statement of a GPIO equals blah 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 blah. And that's how we progress through the rest of this program, which is mostly while and if and bits of delay and signals to sort of trigger the measurement of current. It's all rather clumsy because I don't really know anything about coding. I have learnt a lot making this video, and I will be making a video or two in the future, one about connecting your PICKIT 3 and programming various chips, selecting the right compiler for the chip you're using, and probably choosing the right MPLAB X IDE for your programming device. 3 relatively short videos rather than this big long one, which really is showcasing the repair of a domestic gadget. If you want to see the end result, here it is. Here's the final item fixed, and this is what I came up with. I have a press and release on switch. After releasing, it should go to pulsing blue, which it has done. Sometimes it may pulse red for a few seconds, and it's got a 20-second window in which to settle down, and hopefully it does. And now it will carry on pulsing blue for 10 minutes. The reason for going into a red pulse situation is to indicate that there is an overcurrent. Now, at the beginning, this may be a very temporary one, while the salt solution distributes itself around the bottom. Should the red pulse continue for more than 20 seconds, we go into a lockdown situation where we get a double pulse blue, double pulse red, and the system switches off. And that would indicate we've gone into an overcurrent situation, which we need to investigate the reasons for, which typically would be putting too much salt in. Right, 10 minutes is now up, and we've gone to a steady red condition, which indicates that the process is complete. I'm now going to artificially induce a overcurrent state by adding more salt to the solution. You will see what happens. I've added a quarter of a teaspoonful. The red light begins to flash. It continues to flash for about 20 seconds. The double blinking light indicates we've gone into shutdown through overcurrent, and that situation has to be resolved by draining out the liquid and refilling and putting in the correct amount of salt. That's about it. Done.